Hello guys, we have a question here again given to us by one of our subscribers on our channel. It's Math Time Questions and Answers, a channel that gives you insights about the problem giving you headache at school. Today's question talks about quadratic equation, and it says that given that the roots of the quadratic equation x squared plus 2k plus 2x plus 2k plus 5 equals to 0 are alpha and beta. A. Find the values of the constant k for which alpha is equals to beta. B. For k greater than 0, find the quadratic equation with integral coefficients whose roots are 2 alpha plus alpha beta and 2 beta plus alpha beta. So guys, let's dive in and see how to handle such problems. So in the solution part, we know that our quadratic equation at hand is x squared plus 2k plus 2x plus 2k plus 5 equals to 0. If we compare this equation with the normal form of a quadratic equation, which is ax squared plus bx plus c equals to 0, then we are going to say that the coefficient of x squared is a, the coefficient of x is b, and the constant is c. So we are going to say that a is equals to 1 because the coefficient of x squared is 1. B is equals to 2k plus 2 because the coefficient of x is 2k plus 2, and the constant, the term without x, is 2k plus 5, which is c. And then we know that what? If we are summing the roots of a quadratic equation, we are going to have alpha plus beta, and alpha plus beta is always equals to minus b on a, which is alpha is equals to beta. From the equation, it says that what? Alpha is equals to beta, meaning anywhere we see beta, we can replace it with alpha. So instead of having alpha plus beta, we are going to have alpha plus alpha equals to minus b on a. In this case, we know that alpha plus alpha is 2 alpha and minus b is 2k plus 2. So we are going to have 2 alpha equals to minus into b. B is 2k plus 2 over a, which is 1. So 2 alpha will be equals to minus 2 into k plus 1, because anything divided by 1 is that thing. So in this case, we can therefore divide both sides by 2 to get alpha. So if we divide the left hand side by 2, we can divide the right hand side by 2, and then 2 can cancel 2 one time, 2 can go into 2 one time. Then we can end up with alpha being equals to negative into k plus 1. Again, if we use this same notion to get the product of roots are always alpha times beta, which is c on a. But again, we know that alpha is equals to beta, meaning anywhere we see beta, we can put alpha. So instead of alpha times beta, we are going to have alpha times alpha, and c is 2k plus 5 while a is 1. So 2k plus 5 over 1, which will give us alpha times alpha is alpha squared equals to 2k plus 1. But we know that alpha is equals to minus k plus 1. So we'll replace alpha by minus k plus 1. So we are going to have minus k plus 1, all that squared, is equals to 2k plus 1. You see, the square bracket here is because we are also squaring minus, because alpha includes that minus sign. So in this case, if we square minus, minus times minus is positive. So we are simply going to have k plus 1 squared, and k plus 1 squared simply means k plus 1 times k plus 1, which is equals to 2k plus 5. If we open up this bracket, we are going to have k times k is k squared, k times 1 is k, 1 times k is k, and 1 times 1 is 1. So we are going to have k squared plus k plus k plus 1 equals to 2k plus 5. If we add like terms together, we are going to add k plus k, which will give us 2k, and we'll have k squared plus 2k plus 1. And then when we bring 2k to the left hand side, its sign changes from positive to negative, and when we bring 5 to the left hand side, its sign also changes from positive 5 to negative 5, equals to 0, because nothing will be left on the right hand side. In this case, we can add and subtract like terms. So is there a term in k squared apart from this k squared? No, so k squared will remain. Is there a term in x? Yes, in k, sorry. So 2k minus 2k is 0, and 1 minus 5 is minus 4. So we are going to have k squared minus 4 equals to 0. And k squared minus 4 is a perfect square. So k squared minus 4 is the same as k minus 2 times k plus 2. So we can have k squared minus 4 is the same as k plus 2 times k minus 2 equals to 0. If you open up that bracket, we are still going to have k squared minus 4. So for us to multiply two numbers and the result is 0, either one of the number must be 0. So either k plus 2 equals to 0, which implies that k is equals to minus 2, or k minus 2 equals to 0, which implies k is equals to 2. So the values of k are 2 and minus 2. That's why they said the question talks about we should look for the values of k. So the two values are k equals to minus 2 and k equals to 2. Then the b part of the equation says that with the value of k that is greater than 0, for k greater than 0, which value is greater than 0? Minus is less than 0 and 2 is greater than 0. So for k greater than 0, meaning we'll be concentrating on the value of k equals to 2. So for k greater than 0, we have k equals to 2. So we'll take this value of k equals to 2 and we substitute inside this quadratic equation that has been given to us to have a new quadratic equation that we can use to look for what? The new product of roots and the new sum of roots to form a new equation. So in this case, when we substitute, we are going to have k squared plus 2 into 2, because k is 2, plus 2x plus 2 into 2 because k is 2 plus 5 equals to 0. So 2 times 2 is 4 plus 2 is 6x, and 2 times 2 is 4 plus 5 is 9. So we are going to end up with the new equation, which will be x squared plus 6x plus 9 equals to 0. So this is the equation that we are going to use to evaluate or to look for a new quadratic equation with integral coefficients whose roots are 2 alpha plus alpha beta and 2 beta plus alpha beta. So to move on, we are going to have our new equation, as we already know, is x squared plus 2x plus 9 equals to 0, using the value of k greater than 0, which is 2. In this case, again, we need to list the values of a, b, and c, comparing it as usual. So a is equals to 1, b is equals to 6, and c is equals to 9. So when we look for the sum of roots for that equation, sum of root is equals to minus b on a, which is minus 6 on 1, and alpha plus beta will be equals to minus 6. Product of root alpha beta is c on a, which is 9 on 1, and alpha beta, which is the product of root, will be 9. Now, for us to form new equation, we know that what the new roots of that equation must be 2 alpha plus alpha beta and 2 beta plus alpha beta. So we are going to look for the sum of new roots, which will denote as SONR. Sum of new roots, which will be 2 alpha plus alpha beta plus 2 beta plus alpha beta. So that we are summing the new roots together. So if we sum this, we are going to see that we can readjust this equation so that, or this expression, so that we can easily evaluate it. So let's readjust it and have it in the form 2 alpha plus 2 beta plus alpha beta plus alpha beta. Nothing has changed. We have just changed the order so that we can easily evaluate. Now to evaluate, we can see that if we factor out 2 in the first two terms, we are going to have 2 into alpha plus beta plus 2 alpha beta, because alpha beta plus alpha beta is 2 alpha beta. So we are going to have this. But we know that alpha plus beta is -6 and alpha beta is 9. So we can substitute those values there to give us 2 into -6 plus 2 into 9. And 2 times -6 is -12, and 2 times 9 is 18. So 18 minus 12 is 6. We can also look for the new product of roots to have alpha, 2 alpha plus alpha beta times 2 beta plus alpha beta. So in this case, if we look for the new product of root 2 alpha plus that, if we expand the bracket, we are going to have 2 alpha times 2 beta is 4 alpha beta. 2 alpha times alpha beta is 2. Alpha times alpha squared beta. So that's why we have 2 alpha squared beta. Alpha beta times 2 beta is 2. Alpha beta times beta is beta squared, plus alpha beta times alpha beta. Alpha times alpha is alpha squared, beta times beta is beta squared. So if we rearrange this equation, we are going to have in this second the second and the third term here, we can see that 2 and alpha beta are common, so we can factor it out to give us 4 alpha beta plus 2 alpha beta is common. So what will be left here? Alpha plus beta. If we open up this bracket, we are still going to have this, which will give us 2 times alpha beta. 2 alpha beta times alpha is 2 alpha squared beta. This is still there, plus 2 alpha beta times beta, 2 alpha beta squared, which is this. We have just rearranged so that we can easily substitute these values of alpha plus beta and alpha beta. So in this case, we can substitute those values, and we know that alpha beta is 9 and alpha plus beta is -6. So 4 into 9 plus 2 alpha beta, 2 times alpha beta is 9, times alpha plus beta, which is -6, plus alpha beta, which is 9 squared. So if we evaluate that, we are going to have 4 times 9, which is 36, minus 2 times 9 times -6, which is -108, plus 9 squared, which is 81. So if we evaluate that, we are going to have 117 minus 81, 36 plus 81, 117 minus 108, sorry. So in that case, 117 minus 108 is going to give us 9. So the sum of new roots is 6 and the product of new roots is 9. Now to form a new equation when we have the sum of new roots and product of new roots, the new equation is always in the form x squared minus sum of new roots x plus product of new roots equals to 0. So we'll replace substitute sum of new roots and product of new roots here to have the new equation. So the new equation will be x squared minus 6, which is sum of new roots 6x plus product of new roots, which is 9, and that will give us x squared minus 6x plus 9 equals to 0. So guys, thank you for watching. Don't forget to like, subscribe and share my video, and don't forget to comment on the comment sections with questions that you want us to handle. We also have a WhatsApp group, and the WhatsApp link will be displayed on your screen, so you can use that link to join our WhatsApp group page and ask your questions there, and we'll get back to you. Bye bye, stay with me and remain blessed.